Hello, everyone. I know I'm back so soon. Oh, so much going on. But that is where I got a special request from a great guy who was helped out with our work immensely, and thus was taking some time last night to go over code, and I am digging in again on, yet another project. Now, this is where what we're looking at right now is the Nobrainer.finance code. And so if you guys aren't familiar, that is, and pardon as I focus more on the code, I apologize, guys. Just really want to make a point of going through the code, reviewing exactly what is there and what is going on. Hey, John, glad you're here. Thank you for coming. Why don't you have a goddamn wrench? What happened there? Here, have a wrench. Jesus. I'm sorry. I don't know how I overlooked that. You're like almost always here. You're always helpful. I don't know what the fuck happened. I apologize. So, yes, that is where we are looking at Nobrainer.finance. This is where, a lovely little DeFi, I don't want to say experiment, because, it's a viable product, you know? It's NFTs, art NFTs, with a staking farm around it. So, you could say it's an experiment, I guess, in the sense that no one's really done it before, but I would just point out, this is a full-on collectible product. And they are going to be launching with their staking coming up relatively soon. And thus, I'll leave it up to the team to say exactly when. I don't want to misspeak on that point. But they did say that they wanted this review done right quick. I was telling them normally we need to delay because we're still working on the auditing platform like I've been telling everyone else. But I said, you know what? Can we just do the code review? Can you just go over that and give us your recommendation? I said, all right, well, I can do that. But that's where we're hard-pressed for time. And if I take the time to just go through the code and write you a report, and then you guys make changes, and then I look it over again, and so on, we're going to eat up a lot of time going back and forth. So I said, alright, how about you just give me your code, and I'll do the same thing, but I'll actually just go ahead and make the changes. And then I thought, I'm going to have to do a video on this anyway, so I might as well kind of take the time to point out some of the stuff that needs to be done in code to try to secure these things, and, kind of the headache we have to deal with time and again. Probably the biggest one is why we have to have all of these contracts here. Now, if you're curious what I'm looking at, this is actually the Remix IDE. It's actually a website, but it's weirdly, the best one out there right now. I kind of wish I could get a good downloaded one, but, oh well, what are you going to do? So, in this case, why does it have the backslash in there? That's silly. I did not mean to have that on there. But I thought I'd share that in case anyone's curious. It's a kind of a basic IDE. It doesn't have a lot of the other features that would normally be in place, and some of the tools are a little outdated. Like, the static analysis part. That's, it's good, but it gives you a lot of false positives. But you know what? I'd rather have false positives than a bunch of, missed negatives? No. Yeah, false negatives. So that's why, right now, if we pull up this over here, which is a static code analysis tool, it reports, a crap ton of possible issues, but really, they're not issues, it's just more, that is pointing out that there's some calls here that is not entirely sure that it understands what it's doing, and thus are saying might be an issue. That definitely means you look into them. Duh. That's what I do. But in doing that, you gotta actually dig into the code and say, okay, well, what is it doing? How is it being set? How is it being used? Is this actually a risk? Now, personally, on that, I also like Slither and Echidna for looking at code. Unfortunately, for the past few things I've had to deal with, I just haven't had a chance to get a look at code before it goes out, which, that, I'm sure you can see, is just a nightmare all around when dealing with that. But, that is where, for looking at code and managing things, like I said, I like Slither, I like Echidna. Kin is a bit complicated, and it's useful everywhere, but sometimes it's not entirely needed for absolutely everything you're going through, especially when for a simple project. For the simple ones, though, like, I should say, the simplest tool to use, though, is Mythics. Now, technically, this subscription, you gotta buy it, but I'm not here to pitch the tools. I'm here to point out what's going on in the code and kind of explain what's going on. Now, I know the dev and some large investors are watching. You may be a little surprised. You're like, whoa, that is not the code I handed you. It is the code you handed me. I just added a bunch of stuff. Not to change the functionality, but because, unfortunately, as lovely as Open Zeppelin is, they haven't updated to some of the latest or to resolve some of the latest vulnerabilities. So, unfortunately, had to, like, reuse their libraries, but then also had to move those in to fix some points. Which also made me feel kind of bad, because I told the dev, well, you should just use the Open Zeppelin libraries, and they'd gone back and, like, changed some, and just, like, used direct endpoint. I'm like, oh, darn it, I did not make that clear. I apologize. So that's where I'll just take care of it. I made the mistake in misphrasing it, and, well, that's where I can show you some example. So yeah, when I actually have time to go through code before it gets out, this is the general process we're going through. Now, there's usually some more command line tools. I'll save looking at some of that, because honestly, they're kind of double check each other. Like Slither and Mythics and the static analysis tools, they overlap in a lot of places. Echidna is something totally different, and we'll do that one another time when it's more, because that one's more involved to set up and takes longer to run. But what we start off with right off the bat is the actual tests. Like this, I need to see that there's tests for the code. If there's not tests for the code, I really kind of don't even want to bother touching the project, to be honest. Like, I don't know why anyone would not have their test code in there. If you're at all curious, this is all written out in JavaScript. I hate JavaScript, but I'll put up with it for testing, I guess. And you're literally writing out code saying, okay, well, I'm going to need to talk to this contract, and talk to this one, and talk to this one, and so on. And in order for any of that to work, you actually need a blockchain for it to run on. Well, we got, fortunately enough, this handy little simulated blockchain you can use called Ganache. So between the scripts here, between Ganache, and between the build tool called Truffle, I know memes are all over the place, then you can test out all of your contract code by using, well, technically this is a testing framework called Mocha, but by writing out some JavaScript that defines exactly what you want to have done. Namely, for example, what sort of things do I need to load up to be able to interact with things? So, for example, we can see that there's a Brain loot box, there's a Brain NFT, there's a Brain token, a Brain farm. Are we sure? Well, it's Halloween, so I guess it's the right time for that sort of stuff, isn't it? And then Truffle Assert, which is a library for, checking stuff, verifying that things are correct, doing basic matches. So, when you have tests like this is all written out by hand. So, now there are some tools that can help build up some of this to a degree, but most devs are writing all of this out by hand. There's a lot of work that can go into this, because it's painstaking and annoying. And you're having to put in every little piece and say exactly what you want to have done, and how you're going to talk to the various contracts in there, and make sure that you're testing things that are good and testing things that are bad. So you want to make sure that not just everything works, but also that it doesn't work when it's not supposed to work. So we call that, when testing when everything works, that's happy path or positive testing. When we're testing things that don't work, that's negative or unhappy path testing. So, Dev here has taken care of a fair portion of that. Now I was just running real quick to prep up for the show, make sure that everything's working properly. But, as an example, we do have some nice dev tools to be able to run things. So right off the bat, when I get a project, first thing I do, look at the tests, come in, run the tests, make sure that they actually function. I'll look at the tests to get an idea for, alright, well, are they complete enough? I don't know entirely, because I gotta get into the contracts, but at the very least, I can look through and say, okay, I can see you're pulling out the right contracts that you need to care about. Don't worry that not everything listed here is not shown up there. That is why there's a lot of support going on here. Like, behind, like, the Brain NFT is several of these contracts all layered together to get that functionality. So, all of this being laid out says, alright, we're going to interact with these various tokens, we're going to try various steps, we're going to make sure the system functions. So like I said, first thing I do, run the test. Make sure, does this thing even work when I got it? Well, fortunately enough, it does. Beautiful. So I don't have to worry about a compilation error. If I get something like a compilation error right off the bat, like, I'm done. I'm not saying I'm not working with you, but like, go away. I will talk to you when your code actually compiles. So we can see here, right off the bat, shows some, well, pretty thorough testing. You know, make sure that only the admin can create loot boxes, create the loot box, can deposit brain. You know, they're giving logical names to all the steps that are being done, and this is nice, but technically can't actually know if this means anything. I mean, I can look at this and say, yeah, you did actually do some testing, but I don't know. Did you test everything? I'm not entirely sure. Thus, have to get into all of the code. So, probably the easiest thing to start with, and I'll jump around a little bit here. You'll see when I bring up some of them how some of these are not exactly irrelevant. Like, as if you're looking at code and you're having to review code, you gotta look at all of it, but also I added a fair portion in there, and I'll explain why in just a second here. Now, what happened is I just bring it up and go, okay, well, let's just start at the top, right off the bat. Boom, here we are. We've got brain farm. Alright, let's see what you're doing. Lays out all the various components, like, okay, got it, brain address, so it's got a link to the token, so when it's set up, it's told what token it's going to be working with, and boom, just kind of runs on down that line of having various points. Now, normally, we're not thrilled about having raw addresses here. Normally, we would rather have this be like an ERC20 object or an IERC20, but to be clear, you only really need to worry about the raw addresses when they're coming from unknown parties, like when transactions are being sent in by the outside world. When it's in your own code and it's your own address and you know what's there, not really a risk, honestly, because, you know, it's your thing. Like, the brain is the devs. Like, this belongs to them. They know what's there. And so, in a lot of places, when you're interacting with something you're not entirely familiar with, we'd be saying to make sure you wrap that and handle things, but that can get a little complicated and annoying, and so simple enough to do it here. Like I said, it's not coming from the outside world. One example, though, of what I'm talking about of not trusting things from the outside world is actually where did we put that? Ah, here it is. In context, this actually has a couple functions here. One called message sender, one called message data. And you might be thinking, well, what does that mean? Well, if we come over and look at some of the projects here, some of the code here, which is referring to message sender. Pardon, I've been looking at so much code. Ah, here we go. Here, for example, is what we're talking about. Now, what is actually happening here, and this is a big one for wanting to make sure that something is secure, is that when we're writing code like this, there's a lot of work being done in the blockchain to support us. So that's why you might have heard of it, the Ethereum VM. Probably heard some of your other YouTube channels that you listen to talking about that. You probably heard like Polkadot can run the Ethereum VM. That's because literally there's a little virtual computer running on the miners that is executing this code. Now, when that's happening, the language, Solidity, it's kind of like what's called a framework, and it takes some of the incoming data and puts that together, or at least we write code here that tells the system, hey, I know I'm going to write message sender, but you go do your code stuff low level called bytecode and get that. So in this case, part of the thing that I was looking for and confirming was in place was that, for example, are they actually, one, referring to message sender when they want to get the address of the person that's sending in the transaction? Yes, they are. Beautiful. They're not accepting it as an argument there. It can generally be okay to accept some of these as arguments, and I'll get into where that's coming in and how that's going to play in here. A lot of it comes down to, fundamentally, what you're doing in the code as to how much of a risk any of this is. So, for example, here, because anything could send us a transaction. We don't know what's behind that. We want to be safe with that. And so what we do is called wrapping it. You probably heard of that. Wrapped WETH, wrapped Bitcoin. Similar point here, but in this case, we're wrapping it in another object. In this case, we're wrapping it in a whole other address. So technically, we're saying, all right, I don't actually want the message sender. As in, I don't want to bring all their baggage in. I don't want to bring their functions in. I don't want their code in here. I just want their address. And so, hey, oh, hello. I was helping out a project that's been very gracious and helpful, and nice guy that was asking. And so, wanted to hop in here, get this done while we are, well, while I'm still awake and still got some energy in me. Especially since gave me kind of a chance to explain the sort of things we look for in reviewing code. Now, there's usually a lot of work that has to go into it. We have to make sure we're testing everything. But for the most part, the fundamentals come down to some basic premises, you know? Like, hey, are you actually just accessing raw addresses when they come in? When we say a raw address, we mean something like message sender here. And an example of not doing that is wrapping it in something like, well, this function that we also call message sender, that is just going to pull that out of the Ethereum VM. So we don't need to do anything special to get that. It's just there that we can access it. And actually return out a copy of that address. And so that's why one thing you're looking for is, if you're looking in code and you see a message.sender, like in here, you know, we got is farm address. If it said message.sender here, that might be a problem. Now, in this particular case, where it's doing this check here, okay, well, that's come in, I need to see this little farm address, and I pass in the message sender, might not be a big problem. Kind of depends on what you're doing. But in cases here where if you were accessing that raw address as it was coming in, then there is a chance for what's called a reentry attack. That's where they could, in the process of executing, or sorry, in you inserting or accessing that raw address in here, if that's actually a contract behind that address, not like a basic wallet, then then they might have a chance of possibly being able to insert code. Alright? So, this is where, oh yeah, I got an Genie 9, I'm good. I'm good. I'm probably going to be going to sleep in like a few hours here, but I got time to go through this. So, thank you. So yeah, like I said, these are points you want to look for in going through the code, making sure that something's safe. Something you guys can look for. Like, if you come in and you go, wait a minute, they've got what's called an array, or to be honest, arrays and mappings look kind of the same in Ethereum unless you're declaring them. When you're interacting with them, they can look similar. Not exactly. But in cases like this, if they have something where it's got a name here, and, whoops, not mean to drag that around. It's got a name here, those square braces, looks like the side of a box, and then it just says message.sender, that could be a big risk. Now, in one area where where we can protect against that, is by using other libraries, other code that we can inherit. Now, a lot of this comes from OpenZeppelin, very popular, very good, but they're not entirely up to date. And now that's partly because they're creating code that people can reuse, but in doing that, unfortunately, they are susceptible to some vulnerabilities. And so that's why you see a lot of times here, we'll generally try to encourage people just use the OpenZeppelin library. There's no need to copy that in, but because they made them reusable, there are still some vulnerabilities in there, and thus, very often you have to bring that in, modify it slightly yourself to fix some of those, and then you can start using that. But the very basic premise is good use of, or reuse of that code, Those cases where you can not have to come up with how to figure out to write this stuff, it's already taken care of for you, it's a standardized way, and thus, like, for example, when I'm coming in, and I'm looking through, I can go, oh, okay, there's Reentry Guard, got it, I'm familiar with that. You're obviously, we're not using the OpenZeppelin one directly, we've got our own copy over here, but that saves me a bit of time because I kind of know what I'm getting into at that point, I'm like, okay, I got it. I'm going to be looking at the Reentry Guard. There's going to be a modification. Mostly I just need to look for that modification. Now, another thing to look for, and this is really annoying. This is the whole reason why we got to do this thing with the extra libraries, is you can have up here, what is actually going on here is stating what language and version you're writing all of this in. There's a few ones, like there's Viper, there's Solidity, but in this case, when writing that out, you're also defining what version you want to run in. Now, technically, you can create what's called a floating dependency. You just add that little caret there, that's what that upper arrow is, it's the Shift 6, and then a version number, and you're saying, look, I'm willing to take this version or higher. The problem is that having that floating version, meaning that it could be this or higher, does open you up to a few risks on things that can happen on the minor side, and things that might occur in future versions where things might not be entirely compatible. Thus, vulnerabilities could enter in. So, in this case, this is actually the primary reason why I went through and pretty much removed the direct usage of Open Zeppelin. I had noticed that they still had not gotten around to fixing their use of floating versions for Solidity. And so, alright, well, gotta drag all those in, because can't let that happen there. So, boom, we're gonna take those out. Now, one of the things that highlighted that to me, or at least I should say, made it easier to check, is a tool called Mythex. Like I said, there's Slither. Slither actually produces some excellent reports. In fact, the dev helped me out here and helped me by running some tests to assist me. Why are you being so difficult? Alright, I'll come back to you. Remix is always annoying. It's not usually my main IDE, to be honest. But, in this case, Mythex is a... there we go. That's what I was looking for. Mythex is a wonderful tool for analyzing. Slither is another great one. This is kind of an older one, or an older run here, because we kind of took care of that. But in these cases, you can see that it's going through, compiling the code, and starting to run these little detectors. And so this is kind of the state of things. Now, it's going to tell you a lot of information. So I don't want you to worry here. Like, all these lines, this don't mean there's a problem. This means that they're just... it's going through and identifying what's happening. Like right here, you can see this line, like locked LP farm dot earned address, locked LP farm, and it gives you the row, as in you count down the file where in this source code file is it referring to, and possibly which character. I'll have to double check that. Yeah, that should be which character is, and like in the long line, where is that happening? So in here, for example, it's pointing out, like, okay, well, this thing is running a multiplication on the result of a division. Well, yes, we can see that. We can see that it's doing a bunch of stuff up here that isn't necessarily relevant to the point I'm getting at here, but it's doing, okay, it's doing a multiplication, it's doing a division, it's doing another multiplication, there's another division in there. Now, there is a method to all of this madness. It may seem absolutely crazy what you're doing here. Don't worry, this is what coding is like. There's a lot of weird crap you have to do about moving numbers around and making things match up properly. But that is where it's kind of just calling out, like, this looks a little odd. Now, this is just code, so it's code analyzing code, so it doesn't really know what's going on, but it's like, that seems weird, and conceivably could be a problem. You want to double check exactly what's happening. Well, I can look through and see what numbers are being multiplied, divided, what they're getting out. Like, okay, you make reasonable enough sense. Alright, I don't have to worry too much about what you're doing there. And it just kind of keeps going like that, saying, alright, well, we spotted these things. Again, not entirely sure if it's a problem, maybe something to consider. One thing, though, that it does call out, and if you look at some of the other tests that I've done for earlier things way back, then you can see how it can call out some of those points. I've actually, like, broke some stuff in here to make a point here. Yeah, like, oh, wait, that's not a good one. Let me pull up. Where were we? Yes, I believe the loot box is one such one. Yeah. That is where it pulls up information, tells you, hey, there's all this stuff going on that you probably want to look at. Now, Mythics is still in, I would say they're still in development. Like, the tool under the hood is good, the interface is kind of garbage, and its interpretation of where it thinks the error is a little annoying. Partly because it has to understand the code, but for example, if I click on one of these, bam, takes me right down here to all of the stuff that is going on. Now, it's trying to say, wait a minute, you could have a giant problem here. And it actually gives a link to what are called, vulnerabilities. It's something that reported as being a problem. Now, unfortunately, these links are broken, because, like I said, Mythics is kind of a little messed up. But, at the very least, it does give you accurate information. Now, this doesn't mean that there's a problem. It means that the analysis tool said, I'm not sure this is good. That's why it's marked as a medium, for example. I need you to go look at that and confirm what is going on here. I think there might be an issue. And you can actually see, as I had broken things to kind of prepare here and then came back with others, these little indicators here are highlighting how many problems the analyzer thinks that this code has. And again, not every one of these is an actual problem. That's why there's several. Like, if we looked at the latest run for the locked LP farm, bring it up, and boom, it says that there's 2 low severity risks. I bring it up, I go, okay, well, you're actually showing me ownable, so what's happening? And it goes, requirement violation. Well, this isn't actually a problem. This isn't an error, this isn't a problem in the code, this is quite literally the analysis tool saying, I tried to do something and it didn't work. Well, what did it try to do? It tried to call an only owner function, and it doesn't realize what that means. So, the analysis tool tried to engage with the function, and said, I can't do that, and I don't know why I can't do that, and thus, since I can't do it, I'm just going to throw this error here and say, look, I can't figure it out, I need a human to come look. And that's really the best way to think of all of these, like, warnings or other, vulnerabilities of the tool's report. It's not a clear statement necessarily that there's something going on. It's more like, hey, I don't understand this, I'm a dumb computer, I need a human to come actually analyze it. And so that's why it takes a human, at least for the time being, to go through and analyze these things. Now, these tools can save a lot of time, but still need to take time and look through each of these and figure out, okay, well, are you serious? What are you actually doing? Like, if I look at strings here, it says, oh, there's 7 low vulnerabilities. What is it actually doing here? And again, it's saying this looping over unbounded data. Okay, well, what does that actually mean? Well, if I do, and I bring up the loot box, there it is, brain loot box, where it had this, what it's actually referring to is a case like here. Now, pardon, again, I broke this out to make it hopefully a little more readable. At least it's more readable for me. But this is called a loop. This loop is using some conditions, and I can get into here, but basically it's saying, alright, we need a value to start with, and we're then going to do some logical check to say, hey, should I keep doing this work? And then we're going to keep count of that going through. And then inside that, it's doing that work. Alright, I'm just going to keep doing this until I reach the end, whatever that end is. Well, the point being is, what it's doing right now is saying, look, inside this loot box, there are some cards. Those cards, there's a certain number of cards. I need to know how many cards there are, and for however many cards there are, I need to go through that loot box and get it to cards, and, well, actually I need to get quite a few things. I need to go to the loot box, I need to get card announce, and I need to take out one of the cards, because it looks like, well, this is redeem. You're claiming something off the staking farm. So that is where the tool would say, hey, this is a problem. You have an index here that doesn't have, an array here that doesn't have a finite size, and therefore you could, like, just iterate on forever. You just, if this thing gets larger and larger, you could, in theory, just keep going around and around and around. In fact, technically, it's a way to issue a denial of service attack against the contract. But, again, you have to have a human come in and look at the code. And thus, I can see okay, the loot box is controlled by the owner. The owner is the only one that can do anything with this, and thus they know exactly what they're putting in there. And I mean, how many staking rewards does somebody have? Like, what? I think farm is absolutely insane with like 12. I mean, I haven't seen that many that get that much more over that. Thus, not really a problem. Again, Tool said, hey, I don't understand what's going on. Every indication I'm looking at says this could be a problem. I need a human to come look at this. I come look at it and say, yeah, it technically could be a problem if somebody's a fucking idiot and, like, sticks 500 loot boxes and, like, 1,000 cards in here. But unless you do something silly like that, you're not really going to have a problem. And again, make a point to the dev, they confirm, like, yeah, I'm not going to go that crazy high, we're totally good. Alright, cool. They're aware, they know what the limitations are, and the point being is that there's nothing that a human is sending in that is going to break any of this. In fact, you can see that with the require statements up at the front here. It's doing a check here to say, look, if a human being does pull some bullshit move and actually sends in some, like, bullshit, silly ID that isn't even valid, that's fine. We're going to check that right quick. We're going to make sure, alright, first off, let's make sure it's not 0, because fuck that shit. Make sure that it's actually valid, because, well, if it's not a valid number, I don't want to deal with it, And then kind of moves on to say, okay, well, you just asked about a loot box. That's in this mapping of loot boxes. So, are there even any cards here? Because there aren't any cards. I shouldn't bother doing the rest of this work. Now, what is happening beyond that point, this line, to be honest, I really don't even want to get into this line. This is a nightmare line of code. I hate having to deal with this bullshit. But all this stuff, this CAC 256, ABI encode packed, it's a bunch of stuff for string manipulation and moving things around. Wouldn't worry too much about, exactly what... You guys don't need to worry too much about what is happening here. This is basically a way to shift how some data is formatted so we can work with things a little differently. Like I said, it really has nothing to do with security. In fact, it actually kind of enhances things because all this stuff, remember earlier when I was saying things like message sender, we don't want to actually interact with message sender, we want to wrap that in a function. Similar point here, where they're saying, okay, we actually want to run things like the loot box ID total cards and the loot box ID seed. We want to run that through this encoder and get a value out. Now in this case, it's kind of using some information like block difficulty. This is actually a good one to be using for a random number generator. In fact, that's an important point here, is that's kind of what it's doing, is it's saying, alright, I need to generate a random number, and it's using an interesting method here to pass in some information. We would call these seeds, because they're information being passed in, but some of it is different. Namely, they're adding in a time, so that's always going to be changing. Now, mind you, that's a predictable change, so to avoid having a risk there, they're going to say, well, we're also going to look at the block difficulty, which again, not that big a deal. It's a thing for the miners. Technically, we can get a lot of information about, what is going on, what the transaction that came in is. Most of the time, we don't really care. On top of that, another very important point is, again, not really interacting with the addresses raw, but instead wrapping them in what's called an interface. So, if you go all the way up to the top of the code here, we can see that this is a contract, alright? Brainbox, it is inheriting another contract, and we can get into that here, but in interacting with the Brain NFT, what you can do is write an interface. That's what this iBrain NFT is doing. When you go to the top there, I can see, okay, well, they just put the interface in here. Cool. Could maybe put it in a few other places, but if you don't need it anywhere else, why not? Just leave it here. And as you can see, it provides these, or defines these two functions, but there's no logic to them. Well, that's because it's an interface to a Brain NFT. The actual logic is over here in the Brain NFT. And as you can see, it has add card, mint, and burn. Okay, simple enough. Well, if I come back over to... Yep, there it is. the loot box, I can see that this thing has add card and mint. That means that right now, here in this source code, we have this interface and we can refer to it as if it were the thing. Meaning, we don't actually need to deal with the bare address. We don't need to try to go through some annoying, even more annoying gyrations to be able to invoke a function over there. We can actually just come through and be like, look, I just want to talk to the brain NFT. Here, I'm going to take the brain NFT interface so I can tell Solidity, look, here's how you know what you're talking to, so I don't have to go through a bunch of bullshit for you to be able to tell you what you're going to be talking to and have to figure it out. So I'm going to wrap the NFT address in that, basically telling the system, or telling the language, okay, I know I got an address over here, but I'd like you to treat it as an instance of this brain NFT. We just put an I at the front to indicate it's an interface. And now, in the code, we can just do things like call mint. It's an NFT, you mint NFTs, makes it so much easier. Boom, off we go. So, that is where, when going through the code, like if I go back to the beginning to Brain Farm and kind of start going through things, again, a lot of little stuff you need to dig through. You've got things like, alright, I'm going to set the Solidity version, make sure there's not a floating version there. I'm going to go through and double check the interfaces that are being used. I'm generally fine with the Open Zeppelin ones, but, like I said, they haven't updated, they're still using floating versions, and thus, not the greatest. Has its own vulnerabilities and its own problems. So really, in going through this, we can see that pretty reliable, like right here, not using the raw address, copying that over to a local address. Got some information about, again, this is all just internals for how the system works, just declaring variables to operate with. Modifier, great, we got an update reward. Kind of interesting to stick some logic in here for the update reward, and in passing that through, being able to accept certain points of, alright, well, which one are you going to update, how are you going to manage that and pass that through. This is where, in managing some of these, and I actually kind of left this here as an example to highlight, because technically when receiving that address, we might want to do something further, you know? And so that's where, when working with it, we know that this is a wallet, or this, I should say, this is an address that needs to be updated. So to see what's happening here, kind of like work on the code a little bit live, I can go looking for update address and say, okay, well, where are you using this? What's happening? Because I see this here, and I go like, oh, that's an address variable. I might not be thrilled about that, but it's the modifier that is actually applied to other functions to modify them. Ta-da! And so I might go like, oh, that might not be good. Let's actually go see how it's being used. And then I come down here, and I can see, oh, okay. When they're doing something like staking, they also want to update the rewards, so they put that here in this modifier. And, which means that before this stake function runs, it's going to update, it's going to call this update rewards modifier up above, and I can see, got it, you're passing in the message sender. Perfect. That is exactly what we want. It's using the function, it's not accessing it directly. Beautiful. That means that up here, what normally would be a problem, which is, it seems like you're passing in a raw address into an array, and thus might have some risk of somebody inserting their own code, like if they try to treat a contract as a wallet. Then, down here, we can see, yep, there it is. In interacting with it, alright, so we got that, but we're sending a message sender, good, it's wrapped, we don't have to worry about that. But in going and interacting with these things, see, there's all these cases where we're checking things like arrays or mappings. Again, we can get into another time exactly what all that means. Safe now because it's wrapped with message sender, great. But in dealing with that, that's where one safeguard we can have to protect against that malicious code is Reentry Guard. Or Reentrance Guard? I can never remember. There it is. Reentry Guard. I hate the name. It's so silly. Anyway, Reentry Guard. This provides a nice little set of helpers. In fact, it provides some constructor to set itself up, but it provides a nice modifier, non-reentrant, it is actually doing this basic check of saying, okay, before the other function executes, I want to run this code. And so what it's doing is making this statement to say, alright, somebody's come into this code, we need to mark that so they can't come back in. Meaning that if they try to do something like put in a contract that has some weird implementations of the standard functions, because keep in mind, technically your wallet is just a contract. It's just a standard basic contract with some known capabilities. So, technically, they could just pass in a contract as a wallet. Simple enough. Well, if they do that, like I said, there are some risk that they could try to inject code or do what's called a reentry attack. Well, this is the simplest way to try to protect against that. It's doing a basic check to say, okay, first time it comes in, we're going to make sure, has this been entered? Because, again, the logic here is run this function, or run this modifier. It's going to run all of this code up here, and then this little underscore and semicolon, that is saying, alright, remember that I'm a modifier and I'm supposed to be on a function? Go run that function here. And in running this function here, it then is, joink, going to do whatever is over in that other function. And once that finishes, provided it finishes correctly, then it's going to run this part down here. Now, as you can see, it's doing this basic check to say, okay, have you entered the function? If so, I'm going to mark that. Then I'm going to let the function do its job, and when we successfully complete that, we'll go ahead and reset that. Okay, seems straightforward enough. But what does that actually mean when it comes to securing the code? Well, remember when I said that... Oh, whoop, wrong one. Brain Farm is the right one. Over here, when I said, hey, recall, if this is a raw address, then there might be this chance of this reentry. Well, that's where, when doing these things, and you're interacting with raw address, especially when you're sticking them in arrays or mappings, depending on what you're doing with them, and depending on whether or not someone's implemented some code over on their side, then it's possible for them to say, okay, well, I'm going to re-enter this. So I'm already inside this. Before the function finishes, I'm going to try to re-enter that. Or in doing that, I can try to stick some of my own code in here. Possibly have a way to have you execute my own. Well, there's a few different ways to handle that. You know, we can try doing orders of operations in a different order. We can wrap certain problematic or dangerous memory structures like address here in message sender. But if you realize, if that happens, like, let's just say it's right here. We don't have this function, we're just dealing with message.sender. Okay, well, if it gets to here, and it's that malicious code, and it manages to inject itself, it's going to jump from this point in the code. Because again, when it starts off, it comes in, somebody calls this function, and the system goes, okay, well, first, I need to check non-reentrant. Then it says, okay, I need to check the reward I need to check the reward update. So first it checks the reward update. Sorry, I was getting it backwards from another system and another language. I apologize. Too much going on. Because then it says, alright, you want to call staking? Well, first, I'm going to go call update reward and run that code. And that code up here goes, great. Here is all the stuff I want you to do. And after you do that, I'd like you to call whatever or run whatever function is in there. So, you move the transfer from to prevent possible recursion. Yeah, kind of. That's the basic possible recursion. That's a few points there where one of the things that could prevent that possible recursion, yes, and one of the things that could be cleaning that up. Now, to be clear here, it wasn't the transfer from necessarily in this case. In here, it's just the IERC20 with the brain address, and that just has the standard transfer from. So what I did in this case, in pulling up the IERC20 and pulling it into the project, the whole reason I pulled that into the project was because normally OpenZeppelin has a floating version. In fact, technically, if we come down here to where the dependencies are imported here from OpenZeppelin, and I open up some of these points here, and start digging into... There it is, I believe. Is that right? I can't remember where some of the interfaces were. But if we start digging into this hell, I'll just pull one up and I'll show you guys to make my point. Whoops. There we go. Yep, there we go. IRC20. Then we can see here that it has this floating version here. That's what that little caret there, if you can see that on the screen. That's what that little up arrow is called. That caret is the Shift 6. This means that this code is stating I can run on this version of the Ethereum VM or higher. And that in and of itself is a slight vulnerability. Partly as a safeguard against possible issues. Also possibly safeguarding against potential thing miners can do. A lot of the times what we're trying to protect against is stuff that we're not even sure anyone's figured out how to do yet. We're just putting those checks in. So by moving that, I was doing two things. One, I was saying, okay, this can be a potential problem. Not a big one, not very likely, but why let it go to wait? Why have the risk when I can just bring it over and change that value? Oh, it keeps letting me drag around, pardon. I can just come over here and get rid of that little caret, and thus say, okay, this is only going to work with the Solidity 0.6.2, alright? Again, just a little bit of safety. In the case of Brain Farm, over here, that really doesn't change much of what's going on. It's operating the same, it's the same call, but it is now saying, okay, well, now I know where I'm getting that from. I'm actually going to get that from my own IERC20, meaning, alright, this block of code here that's going to let me interact with an address as if it was an ERC20. And over here is where that's implemented. Now again, this makes things more difficult for auditors because we have to go double check this. If you have just the Open Zeppelin import, I generally don't need to worry too much. Technically, I still need to figure it out and still need to check, but I could simplify things by just like deleting the Open Zeppelin dependencies, re-importing them to confirm I have clean ones. In here, though, I wanted to change that version, and now they're all on 0.6.2, because that's what most of the code was on. And so, in bringing this through, technically I need to come in and double-check what's here. Now, fortunately, I don't really need to do that with interfaces, because interfaces don't have logic. If they were doing something much more complicated, maybe I might need to, but they don't have logic, they don't hold state, they really are just a definition of functions. They don't do anything. It's up to the underlying address or thing they're operating on, namely, like here, where they're taking the brain address and they're turning that into, or saying, I want to treat that as an ERC20 token. Just let me easily get at those functions. On top of that, because there are cases like here, where it's checking balance of, or it's passing those to various, to other functions here, then in doing things like the IERC20 transfer and such, that does mean that potentially there could be the risk of, mostly it's going to be on something like the brain balance when it's in an array, but it could technically happen anywhere, that if you allow a raw wallet address, which we're not, that's why everywhere in the code is this underscore message sender wrapper to handle that, but if we were handling a raw address here, they could try to inject their own code through that process. And thus, in this case, we're saying, well, it's not... Technically, it is kind of recursive, but it's not intended to be recursive, because if they manage to inject that code, then it's possible to have them jump back up to the top of the function and come back in all over again, without ever having left the bottom of the function, without ever completing it. Which is why we have non-reentrant here, because when you look at Reentry Guard, it's doing that basic check. It's saying, okay, when you come in, I'm going to make sure that you haven't already entered this function. I'm going to set a variable that says, yes, you have entered the function, and then I'm going to let the function run. And if somebody then pulls those shenanigans and says, ha ha ha, I've gotten to here, but I want it to end here, send me back to the beginning and let me come in again, we say, okay, well, one, you're not going to be able to do that because we rewrapped your address, so that doesn't work anymore. Two, that's not going to work because you got to here in the non-reentrant modifier and then you jumped out and came back in, which means you're going to run into the non-reentrant modifier again, and it's going to look, and it's going to say, wait a minute, this says you entered, because remember, we came through here, it checks, hey, have you entered the first time? No. Alright. Well, we're going to say that you entered, okay, and then we're going to let that main function run, the other one. And in doing that, we're going to say, well, now that's done, if I was malicious, I'd say, okay, well, I'm going to go back in the top, but in going to try to come back in the top, it's going to come back through non-reentrant, and non-reentrant is going to say, wait a minute, I set status to entered, and you came, and somehow I'm getting called again, and status is still equaling entered. That's not good. And it's just going to fail out entirely. That's what the required sim is doing. If it does manage to execute properly, then it comes out the end, and boom, it resets it to non-entered, and off we go. So I want to be clear here, not exactly trying to achieve or prevent recursion, more just wanting to make sure that even in cases where it doesn't seem like anything could go wrong, that we're doing everything we can to prevent that. It's called defensive programming. You know what? I don't think this is going to be a problem, but it doesn't cost me much to defend my programming and put something in to try to fix that. Now, an example here where things can get, not exactly wonky, but more, you really do have to consider what truly is happening in code. Is this the right one? No, I think it's the feed distributor. Yeah, the feed distributor. Kind of what's happening here, we can say, okay, well, we're dealing with addresses. Unfortunately, we don't have, like, an object that just makes it an address. Partly because, well, I said technically a wallet can be kind of like a contract. It's not a very smart or capable contract. And it doesn't need much because technically, you know, an address can just have Ethereum. It doesn't need any functionality to hold on to that. And so, understandable, we kind of have to do that here. There's not a whole lot of other options. But as we come down, we can see something here, and this typically is considered a problem. Now, not a huge one. I want to be clear here. Like, there were no big problems, because to be honest, there weren't really any problems in the code. Mostly it was me going through the tools and double-checking things, and then in a few places, and like, yeah, I would rather see it done some other way. Here, let me just change that real quick. But it was those cases of, technically not a problem, but, you know, it's resilient, it's stalwart, why don't I make it, like, completely fucking bulletproof? And so, a few changes here and there, but for the most part, I was just, you know, doing some stuff to make the tool happy. Partly because, like, I wanted to get a clean report. Easier to work with that way, although unfortunately their PDF export is broken right now. Thanks, MythX. I'd love to just publish that out and give it to people. But you're not letting me. Fantastic. But in cases like this, like if I go look at the feed distributor, like here's another example of having to make sure that when you're going through code, you're actually going through code. Because if I look at this, it says, oh my god, you've got all of this incredible shit going on. Oh my god, so many problems. Oh no, what are you going to do? Well, okay, I'm going to be a human. I'm going to know that you're a dumb computer, and you don't actually understand what you're looking at. You just think you do. And I'm going to come look and say, okay, what is actually going on here? Well, what is actually going on here, what it's warning us, is saying, hold on now, you made a call to an outside contract, or an outside thing. That itself is a risk. There is a chance that something outside could, you know, whatever you're calling outside, could pull that reentry attack. Well, one, that's why it's got non-reentrant here. So, first off, protect against that. So, we're already solid. Like, we were solid here from the beginning. Then, we can continue on, say, alright, well, how do we make this absolutely, completely fucking bulletproof? Well, here we can say, I know what brain address is. I know what's on the other side of that. I mean, the dev knows, they wrote it, you know? So it's like, there's not a real big problem here. It's not like I'm talking to something I don't understand. I know what I'm talking to. I know what's over there. I know how it behaves. This is fine. But the tool doesn't know that. The tool just saw, hold on, you called something outside your code, and then you proceeded to write data to the blockchain. And there's a risk, because if you don't know who this is, you don't know what's over there, and you access it, and then you come down here and start trying to write data, again, they might be able to insert that code. So again, we're at that point of non-reentrant, we're solid, we're good, we're pretty much bulletproof, and then can confirm, well, if this were anything else, like if you're accepting a message sender or something, I might have a problem. But here, it's your thing. Like, you wrote it, you know what it does, no one else is in control of it, it's immutable, it can't change, yeah, we're good. Now, mind you, that does mean, in looking at this, we're going to want to go double-check exactly what that brain token does, because I may say, like, well, yeah, here it is, you know, I'm looking at this, and the dev is perfectly fine doing this, because the brain address is theirs, so they know it's safe to interact with it like this, it's their code, but I'm not just reviewing the code. I mean, yes, I am. I'm kind of also reviewing what the dev has implemented elsewhere. And so, in this case, I gotta say, alright, well, we're talking to the brain token. Let me go look at the brain token to make sure the dev didn't slip something in there. So, when people say, I'm only reviewing code, I'm not reviewing devs, they're right. I can't review devs, because we get all kinds of weirdos. People are doing things for marketing hype. I mean, hell, I do the same thing. Like, you guys don't see me when I'm talking business. Like, I may be a little goofy and silly sometimes, but, like, very quickly, boom, get down to brass tacks and fucking hard-ass on points. So, in these cases, it can seem a little jarring, especially when you're trying to pick through and be like, well, you know, the devs and the marketing, they're doing their own social management stuff. Like, how much of what I'm seeing or interacting with is truly indicative of, you know, their actual behavior. So, yeah, I'm not reviewing devs. I can't get into their mental state. I don't know what the fuck is going on there. I can't really know what's going on there. But I can review the devs' work. And I can review to see, might they have stuck something in here? Well, that would mean that when I see something like that over here, nothing like that is here. I mean, this is fine code. This is great code. But I need to double check. Hence, over there, we have this call to the brain token. I gotta come over here and double check what the brain token actually does. And thus I can see from that other point, if I bring up the fee distributor again, bam, I can see, okay, we're treating the brain address as the ERC20, and we're calling balance up. Okay, let me go look at the brain token and start digging through. I'm like, okay, so here we are, we got our brain token, alright, constructor, good enough. Just did a one-time minting of the number that's there. Don't worry. Always remember, always, please, always remember, you have no idea how many questions, how many messages I get on this. Please understand, whenever you see these numbers, you gotta trim 18 decimal points, 18 zeros off the end, okay? Sorry, just a side note there. I got so many people that come in and go, oh my god, I think the dev pulled a scam. One, they have a minter in their code. It's in the constructor. Relax, it's fine. It's not a big deal, jeez. Two, I go, oh my god, I think the dev minted a bunch of extra tokens. Like, no, they didn't. We don't have floating point numbers in Ethereum, in Solidity, so they had to add 18 zeros on the end, and to deal with floating point numbers, we just divide by however many zeros we want to cut off. So, we're fine here. But I don't mean to sideline at that point. It's just, I saw that and was like, oh yeah, that's right. I get those kind of questions all the time. I'm fine, but like, seriously, trying to send me private DMs is just not really going to get you much of anywhere. Like, I am swamped. At this point, I think I just have to call bankruptcy on my DMs all over the place. I'm sorry. I really wish I could. But I gotta dig through here, see what's happening. Alright, so we've got things like a bunch of events. Nice. I like to see wordy code that's reporting about its behavior. We've got things like, okay, there's a boolean for whether or not there's an active fee, transfer fee recipient. Alright, all reasonable enough. Yes, that's an address, but I'm going to take a wild guess that the dev knows what's on the other side of that. On top of that, that's touching their fee. So, if the dev wants to, like, put something weird and broken over there and fuck them collecting their fee, okay. Whatever. I'm not really, I mean, I would probably point out to the dev, like, you might want to be careful what you point to this thing and make sure it's implemented properly, but, you know, that's, you know, they pick a Gnosis multi-sig wallet, they point it to a normal wallet, whatever. Doesn't really run a risk to investors, and I'm gonna point out to the dev at points like, hey, double check this here, are you absolutely sure? But this is something that's just affecting the dev, and if the dev wants to take responsibility for saying, yeah, I'm going to make sure that whatever I put in here is safe, great. Because if I search for it, I can see, well, what else is here? Be like, okay, well, no, that's a function. I actually want to go see the use of that variable. Here we are. Fee recipient is receiving an account, and that's only owner. Okay, reasonable enough. If, I don't know, let's double check if that's the only place where it's being used. Nope, technically down here where it's being used in the transfer, but again, it's reusing this transfer function from the ERC20 contract that it's inheriting from. When we say inherit, that means that it's bringing in all of that code into this code to be reused. It's like, great, you're using the transfer function that's defined as part of ERC20. We're good. You're wrapping the message sender in this wrapper function, so we're not interacting with the raw addresses. Also good. We've got the fee recipient. We saw that address up there. You know what? That's on the dev. Not our concern. I mean, I'll point out to the dev maybe it's a problem, but it's like, yeah, I'm going to trust that you know what you're doing. You're one person. You're in charge of the code. You're the one setting this. I think it's reasonable enough to say you can handle this on your own. And if you fuck it up, that's your fucking problem. That's not going to hurt anyone else here with what's going on here. And so, similar points. I'm going through, double checking. All right, yes, there's message sender. I'm looking for message sender a lot. Like, you have no idea how, like, tedious and mind-numbing a code audit is when you're going through this. And this is a small code base. Like, you guys have no idea. Like, I may seem like, flighty and impulsive and stuff, but, like, I'm not knocking the work here or what's going on with Solidity, but, like, I'm used to having to review code that's, like, 80 to 100 of these files. And all of the ones I'm going through are, like, twice as large. That's over in traditional finance, dealing with, like, Java or Python. Well, Python's pretty light, but even then it can get absolutely insane. Erlang's terrible, but I'm not here to talk about that. The point being is, it's tedious. It's a lot of work to go through each individual line and pick things up. You've got to make sure that things are being passed in, like here, for redeem. I see here, it's like, wait a minute, there's an ID being passed in. What's happening? Well, like I said, they're doing all these various checks, so we're good. Perfectly fine there. And so, in doing the audit, just basically comes down to, like I said, dig through, double check everything that's being done, make sure that when stuff is being passed in or referenced, that it's not coming from some unsafe location. Like right here, you might think, wait a minute, there's a loot box, and they're passing in some value for that. Like, well, yeah, but notice it's not actually coming from the outside. It's only inside the code, so this is all entirely safe. So really, long story short, code is solid. Code is good. As I said, I had made some changes to that, and also have a bunch of artifacts. That's what all these various JSON files are, some artifacts from running some various tools against it to analyze that. So I'll just include those here. So this is where I will go ahead and just place that in there. Whoops, I'm a terrible typist because I'm a terrible typist. I don't know what else to say. So in this case, pardon, I PGP sign, or PGP sign all of my commits. So bam, that's there, committed. I can push that up, and then, oh, whoops, gotta punch in the code. Go, there we are. That's what I get for trying to go too fast. Bam, punch in the password, off it goes. It is now pushing up to GitHub, and, like, really, it's just my various notes and the test reports that we were reporting there. I kind of moved a couple things around just because I got different ways of thinking on how I prefer to do things, so pardon as I leave my little mark on your project. I hope that's not too troublesome. But that's where, in coming into GitHub, I'll go ahead and go to my repositories. There we are. Nobrainer contracts. Sorry, I've got to fork your code now. I don't know if that's... Actually, it technically shouldn't be a big deal. But this is how we share code. So I'm going to give them my modifications. In this case, I actually want to push mine to them. So I'm going to say, all right, well, hey, technically I'm going to take it through the... Oh, pardon. I'm looking at the wrong one. Let me fix that. There we are. So, there we go. I'm going to go ahead and issue what's called a pull request. I'm going to create a new one. This is how we share code back and forth. So basically what I did was, they pointed me to their GitHub. I said, great, I want to work on that myself. So I'm just going to take a copy of that. Boom, go off. Yep, I'm going to be sending you a pull request. That's what I'm doing. So I'm going to be like, hey, I want a copy of that while I work. So boom, I'm going to fork that, take that off on myself, and do that. And I'm going to, from here, going to make that from me, pardon as I kind of do my own bookkeeping here, and move that through. Whoops, yeah. So I'm going to send that off to the church here. Sorry, that's the charity here. Audit results. Pardon as I don't leave too descriptive a term there. Sorry. I'm going to go ahead and do that. Bam, here it is. I can merge that into the charity's copy of this on repository. And go ahead and confirm. It's called a merge. We're saying, all right, go take my code and merge it into the copy of the code over here. And then I'm going to take it from here. We don't normally need to go through these steps, but I'm kind of doing bookkeeping to say, okay, I want a copy over there for my own record. And then I want a copy over here for the charity record of what we looked at. And then I want to send a pull request off to Nobrainer. And again, it's just the audit results. So this is a few of the tests that were run, a few of the notes that I have. I did put notes in here. So mostly what I was doing in reviewing this was filling in comments where I was taking what was coming out of the Mythex and reported here. And because they broke their PDF and I can't get a printable PDF to just put in here, I said, well, you know what, here, I'll just put comments in and then explain. So like, all right, if someone runs a tool against this, here's what it's going to say. Here's a link to the severity the tool thinks has encountered. And then I'm going to look through here and say, all right, this is my assessment on that. For example, here I'm saying, all right, this thing is pointing out, hey, could be a giant problem, size of the array, might get out of hand, this is something to address. And then this is me noting and saying, yeah, no, that's not really a problem. The owner is the only one that can call this, so, I mean, we have to trust our devs to a certain point. So, the owner's not going to be dumb enough to fuck this up. And the only way it's a problem is if they let this loot box array get, like, ridiculously large. When I say ridiculously large, I mean, like, we're talking into the hundreds of loot box entries, alright? Hundreds of them. So unless it gets that large, we really don't have a problem here. But either way, you know, I'm pointing out, you're like, alright, hey, this is the point. Not a big deal. The dev is the only one that can call this function. There's no other vulnerabilities here that would make that be a problem. So, we're cool. I know the tool said it's a bug or some sort of vulnerability. It wasn't even really a vulnerability and more just like a check, like, do you really know what you're doing here? Because if this gets insane, it might cause a problem long run. But I come in and see, yeah, no, this isn't a problem. You know, the other people can't call it. It's not like this array, or this one, actually, where we're looping over it, but this array is going to grow wildly out of proportion. And so, yeah, we're good. I don't have to concern myself too much with, you know, what is happening in there, as in, or I should say, I do not have to try to fix what is happening there because it is not a concern. As in, there you go. So, yep, I don't have write access to this repository, but bam, it is off now in the Nobrainer Finance. They can accept this pull request, merge it in as they'd like. Very typically, when receiving something like this, we will take the time to review the request, see what has been modified, what's been changed in there. We have all these little commits here where we're supposed to have our messages and things that are said, so I'm sure that they will take time to go through my notes, confirm that I didn't do something completely fucking insane. Please do. I am completely fucking insane. Well, not completely insane, or otherwise I'd be totally detached from reality, but I am a crazy motherfucker, so please, double check my work. But really it just came down to ran the tools, went through, saw really no problem. It was just like, all right, let me double check, and yeah, I didn't like how some stuff was. That was a personal preference. I figured, fuck it, I'll change it. Also, because I had mistakenly gave the impression that I would prefer that the direct Open Zeppelin libraries be used, and then I realized when I got it back, like, oh crap, that is not what I meant it to sound like. I went through and just fixed all that, so that was there. That way I didn't have to, like, dump on the dev and be like, oh yeah, sorry I didn't word things properly, because, you know, words are hard for doges and visual thinkers, so my bad. Here, I'll just take care of that for you. Sorry. Didn't mean to misconstrue things there. So, otherwise, project's solid. Code is reliable. They've made sure that there's no Reentry Guard, or sorry, there's no Reentry capability because there's a Reentry Guard in there. Made sure to wrap various calls to other addresses, either in the message sender function the message sender function and elsewhere when appropriate for that, wrap it in the necessary interface to talk to that thing. Generally, so long as the dev doesn't try to throw hundreds of loot boxes into those arrays, everything here is going to be perfectly fine as far as I can see. So, we're good. So, hey, you're very welcome. I'm glad you like that, so I'm glad I was helpful, by all means. I hope this helps everyone understand a bit about code. Pardon us, I maybe took this chance to maybe teach a bit more about code. I just thought, you know, you guys see me come in, you see me be all wild and goofy, you see people, you know, you see me maybe not take things too seriously, but you guys don't really see what goes on behind the scenes to prepare for this, you know? You don't see me, like, when I'm just, like, scrolling through things, like, yep, that looks good, that looks good. Typically, I've spent some time beforehand taking a look at things and then come back in and, like, run through that and point that out. So, do any sort of fuzz test or fuzzing. So, for anyone else, that would be fuzz testing in the audit process. We've started doing it in certain cases and would love to get your thoughts on that. Yes, actually, I do make a point of that. I don't tend to, you know, bother running them on the live stream, to be entirely honest, just because they can take a while and they're kind of annoying. But as much as I disparage other auditors' process, it's purely the lack of transparency. Their tools are good, they're competent at the tech. I just think the way they go about reporting on things is bullshit. So, I like the tools. I'll just take them, and this is a good one. In fact, I can provide a link here for anyone that isn't already aware from it. It's from Crytek and Echidna. It's a solid one. It does take a bit to set up, because when you're running through and handling things, you know, it can figure out a fair portion to try to do some automatic test case and such for managing that, but it does take a little bit to set up and get things running, so I don't always have the chance to run this, but that's partly because I've just been trying to catch up on everything. But that's where, with Nobrainer down, with Hippo coming up Saturday to meet my commitment to them, and the auditing platform almost done, then we're good. I got a pipeline of projects coming. Yeld is coming up. Team Finance is coming up. No-Brainer's down, Hippo's coming up, there's more projects that have been talking to me that I need to get to, and with that in place, then, bam, can just start running through our pipeline nice and smoothly. I'm going to work out that nice schedule for everyone, so probably going to be making a point of, like, alright, every Saturday there can be several audits, you know, Saturday, Sunday, several audits, possibly Wednesday, too. That way I can set up a nice schedule, let everyone know working on teams, hey, here's my schedule. Oh, you use Echidna and Chain Fuzz. I had heard of Chain Fuzz. I had not gotten to using it just yet. Only because, you know, like, I just haven't had time to start digging through things. Why are you... It's so annoying when we've got... Wow, okay. Alright, well, hold on. There's a gateway for Polkadot. I'll have to take a look at that later. Jeez. Oh, that's why I typed chain FUXX, not FUZZ. That would do it. Oh, you're terrible. Anyway, I'll come back and look at that. No, I had heard of chain fuzz. I hadn't dug into it too much, and so now that I got a solid recommendation that somebody likes it, then yeah, I'll go through and take a closer look at it. Yeah, it's, well, if they didn't open source, I'd have a real fucking problem with them. Like, I'm sure the devs are confident in everything, but I really fucking hate their process. Like, I mean, again, I'll come back to, it's like, where's your fucking chain of custody? Like, how do I know that what you did in your office was even work? Like, again, it's kind of coming up with my points on when I'm looking at things, and like when I was handling Encore and I was in there and like had to treat it like a hostage situation. I don't know what's going on. I have to deal with the fact that, you know, this kid has control of code and could steal everyone's money, and everyone's like, oh my god, you're thinking that you're saying they could steal everything? You think they might? Like, I don't know if they might. I don't give a crap about might. They can. The fact that the capability is there is enough, alright, for me to take it fucking seriously. Just because it's physically possible, I have to consider it as a high likelihood. I don't even get into character at that point. It's like, the capability's there, therefore I have to consider it a high likelihood, and I have to act accordingly. So, similar points here, when I'm looking at the auditors and the process, I'm like, look, you clearly know what you're talking about with the code, you clearly know how to, like, handle stuff, but you don't understand how the fuck shit works with actual evidence. Like, oh god. Anyway, I had my whole rant. I thought I'd just clear that up of, like, they're good, yes, I like them too, they're cool, but, like, why are you off in a building doing things we don't know with code we never see until it's live? Often you're not even looking at something that's live. Like, I'm of the mind, like, I'm sorry, but if your audit comes out after the pre-sale, we're done. Like, what the fuck are you doing? And the point being is, oh, well, you know, maybe there's a vulnerability and someone hasn't exploited or found it yet. I'm like, yeah, no, you don't find that after it's on the blockchain. Or at least after trading has started, I should say. Anyway, that's why I got the platform. We'll be using that from now on, and that's where I can be much more selective. Not picking the project, but making it clear to everyone, I don't give a crap if you're already out, alright? If you're already out, I'm done with you. No hard feelings, can't fucking work with you, you need to talk to me before it goes out, like these guys. These guys were totally willing to go through the auditing platform, just been harried, and I want to finish one final redesign to, like, really make it nice and tight and secure. I'm hoping anyone that looks through that will just be like, Jesus, you built the most bulletproof fucking system. Most people say it's overkill when I show it to them, but in saying it's overkill, they're like, I can't argue with what you've got here and the results. So, I'll get that in, we'll run things through. These guys were nice enough because, like I said, they wanted to get things done quickly, and they were willing to, like, not go through the platform while we were just a little delayed in getting that cleared up. But, should have it done, should have that ready for Saturday. We'll do the review of Hippo, and should be able to... They did not say whether or not they were entirely ready to run through the platform. I do believe they actually went ahead and deployed elsewhere. That's fine. I will look through the code and confirm. Again, got kind of behind on handling some points. But otherwise, yeah, no-brainer. Code is safe. So long as this is what's deployed, we're totally fine. And when I say so long as this is what's deployed, again, understand, I'm not commenting on anyone individually or personally. Jesus, I know, nobody's saying that. It's like, I'm having to be the impartial hard ass about everything. I have to make it clear, this code is secure. I do not have a chain of custody from this code to the blockchain, but that should be fine. If you go to Etherscan, and you compare it with what's in GitHub, and it matches, then you're good. But I have to say, I'm not involved in getting this on the blockchain, I got no chain of custody, and I gotta say that because I give the other auditors such shit to the point where they, like, pretty much all of them fucking blocked me on Twitter. Like, people have told me, hey, you should go see this one. I'm like, yeah, they blocked me. Nah, that one too. Like, none of them fucking want to hear from me. I don't give a crap. Fuck them. They're smart, they're capable, obviously, but it's like, bitches, where's your transparency and where's your chain of custody? So, that's where this goes solid. Dev, from talking to them, they're solid. The investor that brought this to my attention, also solid and good guy. Had our differences, but we smoothed it over. Got a, like, respect thing going. And otherwise, I would just, as the impartial third party that's got to say these things, when this thing goes out, go to Etherscan, double check the source code, compare it to what's in GitHub, make sure it matches. If it does, boom, you're good. There are plenty of diff tools out there that will help you do that fast and easy. And you know what? You guys let me know when you're pushing this thing out. And I'm not sure I can be there when you do, but I can definitely follow up with everyone to point out to everyone, like, hey, I know we said this. I couldn't get the chain of custody in here because of time and other complications because we're still ramping up. Like, literally, I just got the incorporation, or part of the incorporation paperwork. Still have the tax-exempt filing out being processed for the charity. So, been very busy. But, if you guys like, give me the heads up when you push this out. I can attempt to be available. I can come in either at that time or shortly after that time. Let everyone know, yep, what is on the blockchain is what I reviewed earlier. It should be really quick. So, other than that, just wanted to make sure that I caught up on all the questions. So, yes, definitely thank you for letting me know about Chain Fuzz. I'm going to have to go track that down. Oh, you have an internal version that's more up to date. Awesome. I am envious. It shouldn't matter if they're a kid. What matters is they were a stupid fucking punk that kept lying to me, kept jerking things around, kept saying random crap about... to be honest, I was having to keep a general lid on and things under control the entire time because, like, oh god, this kid's fucking insane. And I got CX dickhead here, who I don't understand their motivations, and I got the social media manager here, and I don't understand their motivations, and if I cause too much of a problem for any of this, I don't know what the fuck is going on. So I'm just, like, slowly coaxing them peacefully towards the LGE to where the funds get deposited, and I'm like, great. Boom! Now that that little crisis is over, and everyone's money is protected, alright, motherfuckers, we had a deal, and you done fucked things up. And you've been a worthless little punk this entire fucking time, saying shit that if this were in any way traditional business, you would be in federal prison right now. So, whatever. But hey, investors' funds are safe. I didn't get much fucking payment out of it. Charity got completely fucking screwed in that regard. But at least everyone's funds got deposited safely. So, I'll call it a fucking win. It's not like, you know, Super Bowl winning touchdown or whatever happens in sports ball, but hey, at least no one got screwed by a fucking nutjob kid. Sorry I couldn't make that clear to everyone out in public. I was really doing my damnedest to keep shit under control behind the scenes to make sure the funds got in, and boom, they did. So, at this point, it's in there, it's a thing, no one can really break it, so, have fun. Other than that, thank you, and I appreciate that. Let me make sure I give some folks wrenches here, because I like to pass that out for anyone that's super helpful and does assist with things. And Rashik? Sorry, it's just a little far away from me because that's on a different screen there. So yeah, Rashik, thank you very much for letting me, confirming that Chain Fuzz is something I should be looking at. Happy to get any of the tools, but we're working on the site. I got no front-end devs. I mean, I kind of have a front-end dev. He hates doing front-end, so he's rusty at it. And I don't do front-end at all. Like, I literally don't know JavaScript. I know enough to get a Mocha framework running and do the test. I have no idea how to do a web page. I could not put an image in a browser to save my fucking life. And I can build you an entire, like, international bank and credit card processing system from, like, computer parts all the way up to the RESTful API, but once you're at the RESTful API, I'm done. I don't have any fucking idea how to do the front-end stuff. So that's what's really delaying a lot of our stuff. just don't have any front-end devs. Got to go track one down and see who can help. But otherwise, the back-end code is generally good. It's all Solidity, so that makes life easier. So, you're very welcome. I'm glad that you got some benefit out of this. I hope you guys saw... I know I didn't go line by line through absolutely everything, but holy shit, there's a lot there. My comments are in here for... in the code, so anyone that wants to go look at the GitHub, you can see in there, you can see where I've identified that various tools or what might appear to be a bug has a comment, made a note as to like what that is, like why that isn't a concern in this particular case, and that's about it. Like everywhere else, there weren't any other problems or any other bugs, and mostly I just had to take my time to go through everything and dealing with constant interruptions with other matters, so that's it. Alright everyone, I got a lot to do, so thank you very much for joining me. I'm glad you guys got some value out of it. Other than that, I will wish you a good night, and I will see you definitely Saturday.